Great minds, welcome to Light Vision Academy. Once again, it is your friend and tutor David Chisholm. Light Vision Academy is dedicated to bringing you videos related to mathematics. I want to give a shout out to all my subscribers, and if you're a first timer, I would love you to click on the subscribe button for you to be notified with all of our videos. Thank you and welcome. Hello everyone, welcome to class today. Today we have a problem of vectors which says given the vectors vector A 2I plus 3j plus 4k and vector B 3I plus 2j minus 6k, show that the cross product multiplied by the dot product of the cross product plus the square of the dot product is equal to the square of the vectors multiplying themselves. Okay, so we are going to start from the right hand side, then we move over to the left hand side. So let's start getting the vector product or the cross product solution. Now getting A times B or A cross B, we use the determinant method. Don't forget of the dimensions I, j and k. Now for the I, we have 2 for the A, 3 for the j, and 4 for the k. Then for vector B, 3 for the I, then 2 for the j, and minus 6. Alright, so we get the determinant of these vectors. And don't forget that the cross product of two vectors is also a vector. Now this is plus, minus, plus. You add their conventional sign, then we have plus I. Now getting that determinant, the I lies on the first row and the first column. We eliminate them. When we eliminate the first row and first column, we have 3, 4 left, 2 minus 6, then followed by minus j. Now j lies in the first row and second column. We eliminate them and we have 2, 4, 3 minus 6, then we have plus k, then we eliminate the first row and the third column. We have 2, 3, then 3, 2. Alright, now here we now take the determinant. Taking the determinant, we have I into determinant is the difference of the cross product, which is 3 times minus 6 minus 2 times 4, which is minus 18 minus 8. Then for the j, minus j, we have the cross product. 2 times minus 6 is minus 12, minus 3 times 4 is 12. Then next one plus k, we also take their determinants, which is 2 times 2, 4, minus 3 times 3, 9. Alright, so we now multiply this. This is I into minus 18 minus 8 is minus 26. Then minus j, minus 12 is minus 24. Then plus k, 4 minus 9 is minus 5. Then this becomes minus 26i plus 24j minus 5k. So this becomes the cross product of A and B, right? So you see that it is also what a vector. Alright, now we now get the dot product of A dot B. Right, now the dot product is always a scalar, which is we multiply this 2I plus 3j plus 4k, then multiply by 3I plus 2j minus 6k. So we multiply this, it becomes 2 multiplied by 3 by their directions. plus 3 multiplied by 2 plus 4 multiplied by minus 6 by the direction I and I, J, J, and K and K. So this will give me 2 times 3 is 6 plus 3 times 2 is 6 minus 24. When we take this, 6 plus 6 is 12, which is 12 minus 24 is equals to minus 12, which is the dot product is equals to minus 12. Now we've gotten the vector product or the cross product, then we've gotten the dot product. Now we'll get the dot product of the cross product. Okay, so which will take us to the next paper. Alright, here we now have a cos b dot a cos b, which is a cos b is equals to minus 26i plus 24j minus 5k. Then we take the dot product of this, which is a b dot a b, which is minus 26 multiplied by minus 26 plus 24 multiplied by 24, then plus minus 5 multiplied by minus 5. So this become 676 plus 576 plus 25. Alright, now when we check this, this will give us 1277. 1277. Now this is what we have as the dot product of the cross product. Okay, now we now add it up to the left hand side, which is a cos b dot a cos b plus a dot b all squared. When we have this, we have a cos b, and a cos b is equals to 1277 plus the dot product. If you remember, gave us minus 12. We square it, right? When we square it, we have 1277 plus 144. When we add this together, then we have 1 4 1 1 1421. Okay, so this gives us 1421. Then we've gotten for the left hand side. We now get for the right hand side, which is we have to show that a plus b dot a plus b plus a dot b all squared is equal to a squared b squared. So this is what we have, and for this alone we have 1277, and we want to get for a squared b squared. So how do we do it? We square for a squared is equal to a dot a, meaning that we get the dot product of a. Now the a is giving us 2i plus 3j plus 4k, right? So a dot a becomes 2 multiplied by 2 plus 3 multiplied by 3 plus 4 multiplied by 4. This gives us 4 plus 9 plus 16. Alright, now 4 plus 9 is 13. 13 plus 16 is 29. So a square is giving us what? 29. Then we get the next one, b square. Alright, now b square will now become b square will now become, if you recall, b times b, but b from the initial question is 3i plus 2j minus 6k. Right, so having b times b multiplies this 3 times 3 based on the direction, plus 2 times 2 plus minus 6 times minus 6. So this gives us 9 plus 4 plus 36, right? 9 plus 4 is 13. 13 plus 15 is 49. So we have that b square is equal to what? 49. So how do we get this now? Now a cos b dot a cos b plus a dot b all squared equals to a square b square. So we already have that a cos b dot a cos b is 1277 plus a dot b from what we already have is equal to 144 is equals to a square is 29 times b square is 49. Now let me check this. This give us 1421 is equals to 1421. Alright, so this shows that the left hand side is equal to the right hand side using the vectors. Thank you.